gravity. But if I'm walking horizontally, are you with me? If I'm walking horizontally, then it's a horizontal motion. That is when you can use your linear acceleration. For vertical movements, it's called acceleration due to gravity. Gravity controls vertical movement. Either you're moving up or doing what? Coming down. If you are coming down, it's positive g, acceleration due to gravity. If you are going up, it's negative g. When we do motion, you know that. So, like I said earlier, before you can get the dimensions of any quantity in physics, you need to know the word formula. For force, it is mass times acceleration. You can use this one to get it. Are you with me? Yes. Mass times acceleration. Our mass is what? M. Am I correct? Yes, sir. Acceleration, we know that it is meter per second squared. That's our unit, right? Meter is the SI unit for what? Meter. Length. Brilliant. L all over S squared is what? S is for what? Time. I will represent it as what? T for dimensions. I use M, L, and what? T in block letters. So I have M over 1 times L over what? T, which is equal to ML over T. I will not stop here as options will not have this one on it. It will be written as ML. I have, what is my power for T here? 1. I said that before. It's invisible, but it is there. Then I'll have T raised to the power of what? Minus 1. Because T is my denominator from your rules of indices. Minus 1. So this is my dimension of force. Of force. Mass times what? Acceleration. We broke acceleration down to meter per second square, the unit. So meter represents what? L. Our time is. Okay, sorry. We refused to put square there. Forgot to put square there. Are you seeing the square? Yes. Square. So it needs to be square. It needs to now be minus what? 2. Brilliant. Minus 2. So any little distraction can make you get a wrong answer. So that is the complete dimension for force. Mass times acceleration. If I give you any question with the formula, first of all break it down. Then you can now use M, L, and T. Let's look at pressure. Pressure is force over area. Force over what? Area. You need to know the formula first before you talk of dimension. We already know the dimension of force. Is that not it? I have M L over T squared. For my force, divided by area. Get me the dimension for area. It's in your notes. It should be L squared. I said in your notes. Have you written it? You are opening. L squared. L times L. Length times breadth. In physics, breadth is still what? Length. So I have L squared there. So this is divided by L squared all over 1. This first dimension is representing what? Force. This second one is representing area. So we just finished fractions. This is the same thing as ML over T squared times 1 all over what? L. I want to cut, so I'll write it in full. This is my L squared. L. Is that not so? So this L will cancel one of them. I am left with M over LT squared. Is that not so? M times 1. M. T squared times L. LT squared. So I'll write this one. No option will have it like this. So I'll write it as M slash LT squared or M to the power of 1. L is a denominator here. Is that not so? To the power of minus 1. Then T to the power of what? Minus 1? Minus 2. Minus 2. Don't worry with time, you'll get it. That is for pressure. Work. You need to know the formula for work before you can make it out. Force times this times. Work is what? Force times distance. We already broke force down to what? ML over T squared. Is that also? ML. Take cognizance that everything we are breaking down so far are derived quantities. And we are breaking them down till they give us a combination of fundamental quantities. Is that also? That is why they are called derived quantities. They are extracted from the combination of fundamental quantities. So this is my force, ml over t squared, times my distance. My distance is also a word, length. Is that also? I told you distance is ground length between points. or locations. Distance is what? Ground length. So it's still a form of length. What is my dimension for length? L. So not L squared. L squared is area. Area. This is just distance. Length. L squared, area. L times L times L. L cubed is for volume. Because we know that length times breadth is area. Length times breadth times height. Height and breadth are also matters of what? Length in physics. So you have length times length times length. Don't mix them. Length is just for distance, displacement, height, one measurement, linear measurement. When you talk of two combinations, it becomes area. 3 becomes what? Volume. So I have my force times distance. My distance is still what? L. Single L. So I have this as this is L over 1. MLL, right? ML squared. All over T squared. Is that also? Which is now ML squared T raised to power what?
Minus 2.
Minus 2, brilliant. Is it coming in now? Little by little? Okay. So we work with momentum. Momentum. Momentum is mass times velocity. Once you know the formula, then you are good to go. Momentum is what? Mass times velocity. So my mass is already a fundamental quantity. My dimension for mass is what? Remind me.
Sir?
Dimension for mass, is it M, L, or T? M, L, or T? Which one? Dimension for mass, length, and time are the three fundamental quantities we use for dimension. M, brilliant. This is represented with M. This is what? Capital letter L. This is capital letter what? T. So the combination of all these ones will give rise to derived quantities. So for mass, we already have mass as what? M. The next thing we are going to break down is velocity. But we know that velocity is displacement over what? Time. God bless you. Over time. Displacement is also a matter of what? Length. I told you displacement is distance in a specified direction. So my displacement is also a form of length because it's measured in meters. And my time is measured in what? Seconds. So I will have mass times meter per second, right? Which is length all over what? T. Which is MLT. But this T is raised to power of what?
1.
Minus 1. So that is for momentum. Mass times velocity. Mass times velocity. So, having said that, I'll give you a short class work you will bring in a jot or something before writing notes tomorrow. So that we can. Is there any time for? Let's do mass now. Let's do it 2 months. What is it?